Hello, in this video I'm going to talk about the third project of the course Computer Vision 2 Applications in Python. And this project is about to develop a radiology AI to detect cases of COVID, pneumonia, or normal. This all based on chest X-ray examples that are provided. So let's see in Kaggle how is the code done. So here we're in Kaggle. This also works in Google Colab, but for me Kaggle was a little bit faster than Colab. So here we're importing all the required libraries. We're using TensorFlow and Keras. We import the image data generator function. We also are going to use the layers from TensorFlow and Keras, which are inputs of max, dense, dropout, and batch normalizations. We're going to use the model from TensorFlow Keras, and we're going to evaluate the model using the scikit-learn metrics, which are classification report and confusion matrix. First, we're going to get all the dataset from the link provided, which is in Dropbox. This dataset contains the training, validation, and test set, which have examples of COVID normal or pneumonia X-rays from the chest. Here we're going to unzip the dataset, and then we're going to remove the .zip file. We're going to set up a 16 batch size and a 21 seed, and we're going to put the dataset path. First of all, we're going to initialize the image data generator for data augmentation. We're going to use the CCA weighting to 0 because the default is 1 exponent less minus 6. And we're going to do some data augmentation operations to avoid overfitting on the model. These are the operations that are done: the rotation range of 20 degrees and also the width shift range and height shift range of 0.2. And this is the train and validation generator, and we're going to have also a test generator. This is not going to have the data augmentation techniques, as this is not going to serve to train. So we proceed and we search all the images that are in this path. We use the function flow from directory using the train validation generator that we declared previously, and that is going to be our train data generator. As here we're going to have the images. We're going to put them as 224 by 224 size. We're going to use the RGB. We're going to set classes unknown, and we're going to use categorical as we have more than 2 options. We have three options: normal, COVID, or pneumonia. And we're going to use the batch size that we declare and also the set. In this step, we're going to shuffle also all the data, and we're going to put the interpolation as the nearest. And we're also going to have a validation data generator, which is in this, which we're going to get the images from this data path, and we're also using the same batch size and the same seed. We're going to have also a test data generator, which is in this path, and for this the batch size is going to be 1 because we need to take only one input at a time. This is telling us the number of images belonging to the classes that we have on the training set, validation set, and test set. And then we're going to use the MobileNet model that it is pre-trained with the ImageNet weights. And as the ImageNet has 1,000 classes, we're setting classes at 1,000, as it is also the default, but we're even setting it up like that. And the input shape of the images. And we are using the max pooling to help with overfitting and also reduce the number of parameters of the model. I tried with other pre-trained models, but the one that gave me the best results was MobileNet. So this is the one that I've saved the model. Here we're downloading the model, and we are going to add the prediction layer, but before some dense layers, so that are fully connected layers. And also we're going to use the dropout layer to reduce overfitting, and also a batch normalization layer also to reduce overfitting. And at the end we're going to add a tree output layer, which is the predictions, and we're using softmax activation. We are using the pre-trained model that was with MobileNet, and we are setting this the inputs of the MobileNet are going to be also the inputs of the new model, and the outputs of the pre-trained model are going to be the predictions of the MobileNet, and we're setting the new model. This is the model that we are going to use for the actual task, which is detecting pneumonia, COVID, or normal chest x-rays. And we're going to use, here is Adam Optimizer with a learning rate of 0.0001. We're going to use categorical cross-entropy loss, and also we're going to evaluate the model with the accuracy metrics. Here we are setting the path where we are going to save the best model. This is the file type that we need to save the model, which is H5. We are going to use callbacks to save the model only when the accuracy improves compared to the previous epoch. And we are using that, and we are also callback to reduce the learning rate to help the training get better in every epoch. Here we're printing the model summary, and here these are the total parameters, trainable parameters, and the non-trainable parameters. And we're going to do the model fit to train the model. We use the train data generator, where we have the data already augmented and shuffled. We're going to train over 8 epochs, and we'll also give the validation data generator that we already have. And we use the callback that we declare. We did the training over 8 epochs. We see the improvement of the val accuracy that get until 0.97, and the loss that is around 13%, which is good. Then we're going to plot the loss and accuracy graphs using the history that we had from the training of the model. We plot it, and we see that we don't have overfitting. At the beginning, when I was using EfficientNet 7 model, I was having overfitting, and I was not using data augmentation yet. and I could see that the validation loss was well above the training loss, and also the accuracy was much lower than 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 training accuracy. So that told me to use another model and also use data augmentation to improve accuracy and loss of the validation. Here we use model.predict to pass all the data from the test data generator and to have the predictions of all the classes that we have in the images. And here we are printing the predictions. As you can see, at the beginning we have the normal, then we have the pneumonia, and then we have the COVID cases. And here we have the classification report, which is the first class, second class, and third class. And we see a good precision, and also we see a good recall and an accuracy of 0.97, which is good for the model that we are searching. Here we have the confusion matrix. As you can see, we have the diagonal elements pretty high, which are the true normal, true pneumonia, and true COVID cases. So we have good classification rate. This is a function to plot the confusion matrix, and here we are only printing the confusion matrix and not without normalization. So 48 images are true normal cases and also detected as true normal. Then 534 images of pneumonia are well predicted as its label. And then we have 503 images of COVID predicted well as COVID. As you can see here, we have 20 COVID predictions that are from the pneumonia class. So these are bad predictions. Also this, but as you can see, is the last percentage of all the data. Here we have the normalized confusion matrix, which shows good classification rate. So the last part of the video is to test the model that we trained to detect the COVID, pneumonia, or normal X-ray samples. But I had a mistake when declaring the classes. That is here. I had not in the correct order. I had normal, COVID, and pneumonia, but it is COVID, normal, and pneumonia, the order of the classes. So that was the reason I was not getting good results after testing the model. But now this is already run, and we defined the test function to pass the image that we want to know if it is of COVID, pneumonia, or normal case. We do the same scaling to the image as we did with the training data. And then here we have the model predict. Here we test a sample from the train set to know that if the model is making good predictions. And as we can see, we are in the COVID folder, and we have a COVID sample, and the model predicts COVID lungs with the confidence. We save the model. Here was another mistake. I was saving only the weights but not the model. So after the answer on the course forum, I realized that, and I could save here. Here I'm saving the weights and also the model. I already stressed in Streamlit, and it gave a good percentage of detection of detection. As you can see, is here. This is the accuracy on the hidden test of the Streamlit app, and here I'm testing with some other samples like pneumonia in the test folder that the model hasn't seen this image before, and it has the 95% confidence. And now I'm testing with another of COVID lungs that is on the test set, and it predicts with 99% of confidence. And then I took a normal normal chest X-ray, and it gave 99% of confidence. So that's a good model, and this is the end of the project.